sine and cosine. Derivative of sine x and cosine x. So let's say that the given function to find the derivative is sine x, and what is the derivative? So how can we find that? Once again, sometimes we put x in parentheses, sometimes we don't. So once again, if we don't know the answer, then the most straightforward way, the most natural way, is to use the limit formula for the derivative, namely the derivative equals limit as h approaches 0 of the quotient difference f of x plus h minus f of x over h. And since f of x is sine x, then of course it just becomes sine of x plus h minus sine of x, all of that over h. And now we need to solve it somehow. Then how do we solve that? Well, we have to use some formulas from trigonometry, like how to expand sine of x plus h. Similarly to a formula from algebra that we knew how to expand x plus h squared. Now it's a different one. It's sine of x plus h. So let me remind you the corresponding formula from trigonometry. Sine of x a plus b. The formula goes, it equals sine of a times cosine of b plus cosine of a times sine of b. This is the well-known formula from trigonometry, and I will use it here. Of course, in this context, a is x and b is h, and so sine of x plus h would be sine of x times cosine of h plus cosine of x times sine of h. So now I will continue from here. So what I'm going to do, I'm going to replace sine of x plus h with this long formula here. So it will become limit as h approaches 0 sine of x cosine of h plus cosine of x times sine of h, and then we need to subtract sine of x and then divide this by h. So this is a pretty long formula, and then what do we do next? Well, here's what we do next. We want to rearrange this a little bit. Like we want to combine this sine x cosine x with this sine x cosine h with this sine x. So I just want to rearrange a little bit the terms. It will still be over h. So I combine this term with this. So it will be sine x times cosine h minus sine x. I will skip those parentheses, and then plus cosine x times sine x plus cosine x times sine h. Next thing I will do is this. I will split my fraction into two separate fractions. One of them will be sine x times cosine h minus sine x, all of that over h. And another one is cosine x times sine h over h. So here's what I'm doing. Limit as h approaches 0. So I will split this fraction. So the first one will be sine x cosine h minus sine x over h plus, and the second will be just this. So it will be cosine x times sine h over h. So it's limit of two quantities, and limit of two quantities equals limit of the first quantity plus limit of the second quantity. So it will end up limit of the first quantity, which is sine x cosine h minus sine x divided by h, and then plus limit as h approaches 0 of the second quantity, which is cosine x times sine h over h. And now I want to calculate these two limits individually. So this limit and this limit. So the first limit of sine x cosine h minus sine x over h so we will factor out that sine x. So it will be limit sine x times cosine h minus 1 over h. Now I will split these two limits again, this into two limits again. So it will be limit of this times limit of that. But since sine x in itself doesn't have h in it, so in terms of h approaching 0, sine x is a constant. So its limit will be just sine x. But the other part does have h in it, so it will be times limit of cosine h minus 1 over h as h approaches 0. Now this second limit we can calculate numerically, and this second limit actually equals 0. So the final answer is sine x times 0, which is just 0. So what I'm saying is that this first entire limit equals 0. Now let's calculate the second limit. Limit as h approaches 0. Cosine x times sine h over h. Again, I want to split it into two limits like this. So I first calculate limit of cosine x and then limit of sine h over h. And again, since cosine x doesn't have h in it, so it's a constant, and the limit is the same thing, so cosine x times. We only need to calculate limit of these things. It will be limit as h approaches 0, sine h over h. And again, this limit can be calculated. And now the second limit, as h approaches 0, cosine x times sine h over h. Again, it can be split into two limits, limit of cosine x and limit of the rest of the expression. And again, since cosine x does not have h in it, so it is considered limit. It is considered a constant while we calculating this limit. So the limit of that constant is the same constant, so it will be cosine x times, and we still need to calculate limit of sine h over h as h approaches 0. And this limit we have calculated numerically, and this limit equals 1. So altogether we have cosine x times 1, which is just cosine x. So what I'm saying is that this second limit equals cosine x. So altogether we have 0 plus cosine x, and the final answer is cosine x. So here is the rule. When the function is sine x, the derivative is cosine x. Now I want to explain one more formula. Let's say f of x equals cosine x. What is the derivative then? Now you may think by association that maybe then the derivative is equal to sine x, but no, it's not so. In fact, the derivative equals negative sine x. And how do you know that? You don't know that until you actually work it out the same way. So we want to calculate limit using. You want to calculate the derivative using the limit formula, and the result of that limit formula eventually will be negative sine x. So let's do it. So f prime of x, again, the limit formula goes limit as h approaches 0, f of x plus h minus f of x divided over h. Again, because f is cosine, so it's just limit as h approaches 0, cosine of x plus h minus cosine of x over h. And again, we want to replace cosine of x plus h with whatever it equals according to formulas from trigonometry. And the formula is this. Here's the reminder. Cosine of x plus h equals cosine of x times cosine of h, so it's different from sine, and subtract sine of x times sine of h. So this is the formula for cosine of x plus h, and this entire formula goes here. And so it will end up as limit h approaches 0. So this first portion is replaced with this long formula, so cosine x times cosine h minus sine x times sine h, and again we need to subtract cosine x because of this and divide by h. So now again we need to do some kind of rearrangement for this formula. And the rearrangement we want to do, we want to combine this cosine x with the first term, cosine x times cosine h. So it will be limit cosine x times cosine h and minus cosine x, and then minus sine x sine h over h. Now again, like before, I want to split it into two separate limits. One limit will involve this and the other will involve that. So first of all, I will split the fraction into two fractions like this. Fraction cosine x plus, cosine x times cosine h and minus cosine x. All of that over h. And minus, actually, because of the minus here, we can put minus, and then it will be sine x sine h. Sine x sine h over h. So limit of fraction minus another fraction. Again, limit splits as limit of this minus limit of this. So it will end up limit as h approaches 0 of all of this. Cosine x times cosine h minus cosine h, all of that over h, and minus the other limit as h approaches 0, which is just sine x sine h. So sine x sine h over h. And again, I want to calculate both limits. So to calculate this first limit, here. To calculate the first limit as h approaches 0, cosine x times cosine h and minus cosine h, minus cosine, it's cosine x here, cosine x divided by h. thing I do, I factor out the cosine x, because there's cosine x here and here is limit. H approaches 0. Cosine x times, and here we have cosine h minus, and here we have 1. Cosine h minus 1 divided by h. Now, it will be again limit of this portion and limit of this portion, but this portion is constant, it has no h in it, so limit of this portion is the same, so it's a cosine x times, and then we still need to do limit of this, cosine h minus 1 over h. And again, this limit can be calculated numerically. As h approaches 0, this limit actually equals 0. So altogether we get cosine x times 0, anything times 0 is 0, so the answer for this limit is just 0. Now let's calculate the other limit. It will be sine x times sine h divided h. This limit, again we do limit of this and times limit of the rest, but again this expression sine x is constant, so derivative of the constant is the same thing, so it will be sine x times. Now the limit of this portion has to be calculated, so it's a sine h over h. And this limit, actually, we have calculated numerically it equals 0. So altogether, we get this limit equals 1. We have calculated it numerically, limit of sine h over h equals 1. So altogether, it is sine x times 1. So it equals sine x times 1, which is just sine x. So the second limit, this limit here, happens to equal sine x. But now we've got 0 minus sine x, so the overall answer happens to be negative sine x. Once again, the other rule, the rule about cosine, is that if you start with the function cosine x, then the derivative of this function is negative sine x. So let me write this down. F of x equals cosine x makes f prime of x equal negative sine x. So derivative of sine equals cosine, while derivative of cosine equals negative sine. Now, what kind of problems you can expect on a test using this? For example, let's say that k of x equals 3 sine x plus 5 cosine x. 5 cosine x. And then find the derivative. So the derivative of this function equals 3 times, and derivative of sine is cosine, so it's a cosine x, plus 5 times, and derivative of cosine is negative sine x, so it will be minus 5 times sine x. So this is how we can calculate derivative of expressions or functions involving sine and cosine. And now I want to mention one more thing about sine and cosine. Pretty interesting thing is higher order derivatives of sine and cosine. Higher order derivatives of sine x and cosine x. In fact, they are pretty interesting, like I said. So let's calculate. For example, let's start with f of x equals sine x. And the derivative of sine we know is cosine x. Now let's do the second order derivative, which will be, of course, derivative of cosine, which we already know is negative sine, so it's a negative sine x. The third order derivative will be derivative of negative sine. Now negative will be negative, and sine derivative is cosine, so it will be negative cosine x. Now let's do the fourth derivative. Sometimes denote it like this, fourth derivative. It will be negative, but derivative of cosine is negative sine. Therefore, it will be negative sine x, which is again sine x, which is the same as the function itself. And what it means that if you do one more derivative, like fifth derivative, it's derivative of the sine, which is we already know is cosine x. So derivative of fifth derivative is the same as the first derivative. Similarly, sixth derivative will be the same as the second derivative. So it's all repeating. So derivatives are cyclically repeating with the period of 4. Cyclic repetition or loop with period of 4, because every 4 formulas repeat. So see sine, cosine, negative cosine. Then again sine, cosine, negative cosine. So it will be repetition with period of 4. This happens with sine, and exactly the same thing happens with cosine. For example, start with cosine x. Then the derivative of cosine x we know is negative sine x. The second order derivative is derivative of negative sine, so it will be negative cosine x, because negative stays and then derivative of sine is cosine x. The third order derivative is its derivative of negative cosine x, and this is negative, and derivative of cosine is negative sine. So it's actually sine x. Negative sine is just sine x. And the fourth derivative is derivative of sine, but that is cosine x. And now fourth derivative is exactly the same as the original function. And what it means that the fifth derivative will be derivative of cosine, which is negative sine x, which is same as the first order derivative. Similarly, sixth order derivative is the same as second order derivative, etc. So the same cyclic period, cyclic loop of period of 4, it applies to both sine and cosine. If you start with sine, then higher order derivatives will be sine, cosine, negative cosine, and then repeat. If you start with cosine, then the higher order derivatives will be cosine, negative cosine, sine, and then again repeat. So either way, it's a loop with period 4. So it's interesting property of higher order derivatives of the functions sine x and cosine x.